So now that you have researched the escape pathogens and done your presentations on them, now this is where our master plates come into play. So to enable us to see whether or not our bacteria are making antibiotics, we have to have a target for them to make antibiotics against. And so if you remember from last time, the escape pathogens are the pathogens that we see a lot of antibiotic resistance with. And so we're going to have your soil-borne bacteria versus the pathogens. Now, for this lab, of course, the first thing that you're going to do is gram stain the escape pathogens to see whether or not they're gram-negative or gram-positive. Once you have gram stained the escape pathogens, you're going to select 1 gram-negative and 1 gram-positive to test your soil-borne bacteria against. Now, of course, in order to do this, the first thing you're going to do is gram stain, but after you've gram stained, you're going to select a gram-negative and gram-positive pathogen. Now, more than likely, your escape pathogens will be in liquid culture. You'll have to check with your instructor. Here I have them just as colonies. And so I have 1 gram-negative and 1 gram-positive escape pathogen on this plate. And so what we're going to do, of course, in order to test our bacteria against this, is we're going to take a plate that we've made exactly the same way as our master plate. So what we've done ahead of time is we've gridded it off, and we've made the same numbers here that we had for our master plate. Okay? And what the only difference that we're going to do here in methodology is we're going to, instead of putting on these bacteria first from your soil-borne master plate, the first thing you're going to do is you're going to put on the escape pathogen. And then we're going to overlay your bacteria on top. Now, in order to do this, we're going to take a sterile swab. And again, if you're using liquid culture, you're going to dip that swab into the liquid culture of bacteria. If you're using a solid plate, you're simply going to dip this into a single colony. Okay? Now note how quickly I did that, and I did not take a whole lot. Again, there's 100 trillion bacteria on the tip of this little thing. Okay? So the whole point of this, of course, is to make sure you get even spread all over. So I'm going to start at the top and very slowly and methodically make my way down. And again, I'm not looking for single colonies this time for the escape pathogen. I want to make sure that it's evenly spread. But note, just going one time, I might have missed some spots, right? So what I'm going to do is I'm going to simply turn it a quarter turn, start back at the top, and move all the way down. Okay, and again, I'm trying to cover this entire plate with bacteria. Note, that's not going to be enough. I might have missed some spots, so I'm again going to do a quarter turn, start back at the top. And again, I want to completely cover this, and then we're going to do that one last time. So this is called the plate coverage method. And you want to completely cover that as much as you can. Okay? Once you have that nice and covered, note that your swab is now biohazard. We're going to put that either in your blue buckets or your biohazard bag. Now it's time to transfer the bacteria that you have on your master plate to this plate. Now, note that there's already bacteria on this, so it's very important you're just going one way from your master plate to your escape master plate. And so to do this again, you're going to take your sterile toothpicks, and you're simply, again, going to take one of these positions. So I'm going to start with position 1 and simply barely dip into there. Again, if you see bacteria on here, you have too much. And again, I'm going to go back to position 1 on this plate and make a little X. Okay? Once I'm done with that, that becomes biohazard, and that's done. And you're going to repeat that for that entire plate. Okay? Now, once you're done with one escape pathogen plate, say this was a gram-positive pathogen that we're testing against, you're going to make another one of these plates for your gram-negative. Okay? So it's the same process. You'll take out a blank plate, you'll label it, you'll have this grid pattern, you'll make the grid pattern. And again, it's very important just to make sure that whatever number you have here, that number is the same as this one. And so 1 goes to 1, bacteria 2 goes to bacteria 2, bacteria 3 goes to 3, and so on and so forth as you go along. And what you should end up with after this is 2 plates that have the grid pattern on it, the pathogen, the escape pathogen on it, all evenly spread, and then your bacteria patched on top, either with an X or whatever symbol you're comfortable with. And then we'll look at these next time to see whether or not they have any activity. So last time we were all talking, we put together those plates with the escape pathogens versus your bacteria. Unfortunately, my plate didn't work, but a colleague of mine made a plate that we actually saw some activity. So here is his grid pattern. He just did 3 down and 4 across. And I want you to notice something. So note here, the 1, 2, and this 3, this number 1 bacteria didn't show any clearing around it, but if you look at number 2 here, there is some clearing around that. That clearing represents that your bacteria, that soil-borne bacteria, is killing whatever that escape pathogen is. Therefore, it is producing antibiotics. And so you have just discovered from your soil sample an antibiotic producer. Now, some of you in the class might not have gotten any. Some of you guys might have had multiples. And so what we're going to do from this point on is we're going to simply work on the positives. And so if somebody at your table has a positive, you are going to now be working with your bacterium, or their bacterium. And so that everybody has the ability to see what antibiotic production in bacteria look like. And so we're going to continue to work up this exact bacteria to look at antibiotic production. So last time we found that we had some activity with this bacteria with antibiotics. And so what we want to do now is, we can't, of course, use this plate for screening or for separating it because there's your escape pathogen on here mixed in with your bacteria potentially. And so what we need to do then is we need to go back to our master plate. And so if you remember, this is bacteria 2, column D. Again, your numbering system might be different. But here, again, we have bacteria 2, column D. And now this is the master plate. Remember, the whole point of the master plate is to have everything separated. Okay? But depending on how well I did the separation, there might be multiple bacteria in there. I just don't know. So to figure that out, what we're going to do is called the streak plate technique, where we can do 4-phase streaking in order to separate single colonies from here. Now, in order to do this, again, I have to use a new plate. Now, again, the rules of microbiology state you have to have your name or initials, what you're putting on, so you can call this your streak plate of whatever your bacteria. This is going to be 2D, and then the date. Okay? So now we're going to utilize our loops and our incinerators. Now this loop, again, is going to be for picking up bacteria. This thing's an incinerator. It gets red hot. It takes about 10 minutes to have it on, so your instructor will write a note on your board in the beginning on the board to turn them on at the beginning of class. And so what you're going to do to sterilize this loop is to leave it in here for roughly 5 seconds. After that 5 seconds, when you pull it out, it's going to be nice and red hot. If you immediately went to your bacteria, all of them would die, and then you've ruined your experiment for the entire semester. So please wait about 10 seconds before you get your bacteria. Okay? Once you're ready, you're going to match your bacteria to what you have here. So I'm going to find 2D, and again, I'm just going to touch a tiny, tiny bit of it. Don't need to do a whole lot. You just dip and go. Okay? Now, what I'm going to do here is I'm going to simply rub some of that on the top of the plate. Okay, that's just to separate the initial amount. But there's now 100 quadrillion bacteria on there, and there's still 100 quadrillion bacteria on my loop. So what I'm going to do is I'm going to sterilize my loop again for about 5 seconds. And then I'm going to take it out. That's going to get rid of any of the residual bacteria on here. And then what I'm going to do here is I'm going to look at my initial streak, and I'm going to say, okay, I'm going to take a little bit of that from there and scoot it over and separate it again, being very careful not to go into my initial streak. Okay, and then I'm going to take my loop again, incinerate it, to get that residual amount of bacteria off. Okay? Then I'm going to go into my second streak, scoot a little bit of that stuff over, and separate it. Okay? Some people say this kind of looks like pie slices or pizza slices. If your slices are not that good, don't worry about it. This is not an art contest. But note that each time I'm streaking, I'm just taking a little bit out and separating it. So by the time I get to my fourth streak, which I'm going to do now, if I wait 24 hours, that should enable me to see single colonies. Okay, so I'm going to do that fourth streak, scoot it over, and wipe it down. And then in 24 hours, we'll take a look at how our bacteria look. So we are ready to see our results of our streak plate. And so remember last time we did the 4-phase streaking, incinerating our loop each time. So this was our first streak, and notice how full of bacteria that is. So we can't really see single colonies out of there. Then we did our second streak, and we started to get less. Then we did our third streak, and now we're really seeing single colonies. And then our fourth streak, all the colonies are nice and separated. And we're going to use these single pure colonies for the rest of our testing, for colony PCR, for looking at biochemical results and things of that nature. But first, since we now have this as a pure culture, and we have determined that this one is now producing antibiotics, we want to be able to save it forever. The problem is, of course, is that there's a limited amount of time that the bacteria can live on this plate. The plate has limited nutrients. And so what we're going to try to do is put the bacteria in a state of stasis, where it's not really doing any metabolism, but it's going to stay alive, but not actually eating, feeding, or doing anything like that. And so to do that, we're going to freeze it down at minus 80 degrees Celsius. There's no place on Earth that actually gets that cold, by the way. But you might be wondering, well, how in the world can you freeze a bacteria and have it still be alive? Well, what we're going to do is we're going to use some chemicals. So we're going to take this cryogenic vial, and we're going to put some media in it. And it's going to be up to your instructor what media you put in. Most time this is going to be LB media mixed with a substance that we call glycerol. Now, glycerol is a viscous solution that prevents the crystallization from forming inside the cell wall when it's freezing. And so the crystallization when you're freezing something is actually what usually kills it. And so if you can prevent that crystallization, the bacteria can be in here in the solution of 20% glycerol mixed with your media forever at minus 80 degrees. And then when we're ready to work with it again after storage, we can just simply take a loop or a toothpick and then put it on the plate. It will start growing again. And so this is a good method for saving bacteria in storage basically forever. So all you're going to do here is you're going to either take a toothpick, a pipette tip, or even a loop, and you're going to take this and you're going to just, again, you need a very, very small amount of bacteria. Pick up one colony with your loop, open up the lid, and again, this will either be pre-filled for you or you will fill it up with about 1 ml of 20% glycerol with your media, and then you inoculate it, and then you incinerate your loop, and this is ready to be placed at minus 80 degrees for storage. Okay? Now remember, this is an unlabeled tube, and we always label, of course, with what it is, what your initials are, and the date. Okay, so there's a little white part here that you're going to label with. Again, prefer to label before, so I'm going to do my initials, what the bacteria is, and remember this is going to be related to the spot on your master plate, whatever you named it. So I'm going to do AK spot 2 for me, and then today's date. And that way we can always reference it back to whose this is, where they got it.